For those that read the description, this is 0.5, and we get something like curve that just goes up, the cubic between 4 and 5. Can't show that now because we have got crashes and I was editing anyway. So in this code, find extreme, which means, well, we just assembled a new value at W. And then that was inserted, in this case at the end. And a node on the left and the right of the new sample has been determined. Well, the node that exists. So there is no node on the right. And there is a node on the left. So this is false. There's no node on the right. But there is a node on the left. However, that node does not have an extreme. Because it's just monotonically rising. Read the description if you want to follow that. So this is false. So this is also not doing anything, and neither right has extreme nor left has extreme is set. And that went horribly wrong then later. So now I'm trying to come up with some code that checks this special case. No, these are just variables. Variable. Hello, deep area. This case can only occur if the horizontal direction has been determined already. Because it can only happen if you come from a found local extreme, which means that, well, that must be the last local extreme then. Which means that the last extreme must be set. And as explained here, well, that means they are set at the same time. So if horizontal direction is not undecided, but it is left or right, then the last extreme cubic is unequal chain end. So we do have a local, a last extreme. Now the local extreme edge that we get here by calling this member function on the local extreme of the last extreme cubic for h with h direction is simply the point that the left or right most point of the 3 points that were used for the cubic. So in my current example, let me run it again. Quit. It's too bad I have the last executable crashes. Okay. The thing is that 4 here is a little bit before the maximum. Yeah, the maximum is like here. Well, the maximum is where the arrow is drawn here, the green arrow with the 3 through it. That's just after 4. So the derivative in 4 itself is still positive. And then we get the maximum and then we go down. But the cubic that is being fitted, I think here we have point 1 is on the right and then point 2 is on the left. So 1 is closer to 3 than 2. And therefore it did fit 4th degree polynomial through 1 and 3 and 4. Which is this green curve, which then has a minimum around here, 6.3. And we just jump to that. And well, that's reasonable because we are looking for the next minimum on the right, on the right of this maximum, right? But then the cubic between 4 and the new point is monotonically rising. Okay, I have 0 views now, so I should not explain anything. Let me just work. Anyway, local extreme edge is 0.4. It's the one on the edge to the right. Boolean cubic adjacent to last extreme means I think that I think we should have a heavy preference for the cubic that is attached to the last extreme. So going to the right, that would be the left cubic. If the left cubic does not contain the local extreme that we're looking for, in this case a minimum, for example, if you still new sample is on the slope down, then we would be more interested in a cubic on the right of the new point. If there is a cubic on the right, which would only exist if there was already a sample even further to the right for some reason. But okay, that happens sometimes. But in order to use the cubic on the side of H direction of the last sample that we took, we must be certain that the cubic on the other side of the measured sample, so the one closer to where we came from, does not skip a minimum. So it does not skip the local extreme that we're looking for. And right now, before today, let's say, I was just detecting if that cubic did not have any extreme at all, or not the extreme that we were looking for. And then I would say, okay, then we can skip it. But that turns out to be incorrect, because it can also be monotonically rising. Even then it does not contain a minimum that we're looking for. But that doesn't mean that it's monotonically falling. I mean, hey Abhimanyu, good that you're here, because I had the feeling I was talking to myself. I'll run my program again and explain what the exact problem is with the graphics at hand. So I zoomed in on the problem case here. I have no idea what that is now. So the problem is we just found this maximum and now I want to find this minimum. And then we take a new sample. Now suppose the new sample would be here. And we already have a sample here. Suppose we have a sample here. And now we take a new, it will just an old sample that happens to be there. And now we sample here. Then we have a left cubic and a right cubic. Now the cubic on the left would be the one between 4 and the new sample. And the cubic on the right would be between the new sample and the sample that was already there. And then you could say, well, if this part does not contain a minimum, and this part does contain a minimum, I already explained this like twice, and every time my viewers dropped, the viewer count dropped to 0. So if you want to have it explained, then please tell me. Because it seems now that you only want to know about a calculator. I'm totally happy not explaining it. Then I just go coding. Which makes sense if you would not want to follow what I'm coding. Okay, so assume we have a point here. Then if the next sample is here, then the reasoning was if this cubic does not have a minimum, and it doesn't, then we have to use this cubic. Yeah, so we would find the minimum of this cubic, which is super logical. However, it turns out that it is possible to mark this local extreme as a local extreme while the rightmost sample, which is 4, is still before the maximum. So the derivative in 4 is a little bit, but still positive. And now the new sample that I take is all the way over here, and or over here maybe. And then the cubic that is fitted through 4 and that new point, taking into account the derivatives, is just going up. 4 is going up, and it continues going up and up and up and up and up. Which means that my algorithm said, oh, the cubic between 4 and the new point does not have a minimum, and it doesn't. Therefore, we can skip it. But that reasoning did only hold for a sample here. Because this part does not contain a minimum, we are only interested in what happens on the right of the new sample. But if my sample, well, let's say if the sample was here, then we would get a cubic that has a minimum here, and then it does have a minimum, and then we would use this cubic, and therefore jump to the minimum of that cubic. Yeah, so that's all good. But if you move the sample further and further and further, then at some point it can happen, apparently, that there is no minimum in this cubic between 4 and that point. Because in 4, the derivative is already positive. So we just go up, 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 up. And then it is an error to say, oh, there is no minimum, therefore we must look for what a minimum on the right of this sample. No, we must look for this on the left of that sample. So in order to not make that mistake, I need to be able to make the difference between this one and that one, and that is very easy. This one is going monotonically down, and this one is going monotonically up. So if our new sample is before the sort 4 minimum, then of course the derivative in the new sample is negative. We are before the minimum. So if this thing does not contain any local extreme at all, then and the derivative is negative here, then we just can skip it, and then the minimum is going to be on the right of the new sample. Well, if the new sample is here and there is no local extreme at all, it's just monotonically rising, then something must be wrong, because this was a maximum. And now we're heading to a maximum, because the derivative at the end is positive. So we're going up, up, up until we're no longer going up. So we're just before a maximum. But this is a maximum. You cannot have 2 maximums on a row. There must be a minimum in between. So alarm bell should go off. However, I cannot just look at the derivative, because it could be that the next example is even further and is here. And now it is possible that you would get a cubic that has a positive slope here, and then has a maximum, and then goes down and matches this derivative at this point. Something like that. That's possible. In which case it does not contain a minimum and the slope is going down, but it is not this one. So how do I make a difference between this one and this one? And the only way you can tell that difference is by looking at where that maximum is. Now in this case the maximum will be over here, and in this case the maximum is like totally on top of the last maximum that you found. I mean, it's like it's 1 pixel to the right. So that's what I have to use. However, I just couldn't get it into my code, because the code was assuming certain things that didn't work anymore. Okay, so that was the backstory. I don't know how many people left in the meantime. I'm definitely not going to explain this again. Now I'm just going back to coding. And then anyone who followed this might be able to follow it. Otherwise you will not be able to follow it. So instead of talking about the left cubic and the right cubic, I probably shouldn't, you know, because or maybe it's more complicated than that. So this part just finds the cubic on the left and the right of the new point. They always are initialized if they exist. If they don't exist, then that's not a problem. I mean, it's just then we are at the end. So the left cubic in this case, in the example case, always exists. So left cubic will always be initialized. This is the analyzed. Sorry, do I already have a left cubic? Left node cubic. Yeah, I already have that. Okay. So the new node was inserted in the chain, and that caused the cubics to be initialized. So we do have a node on the left which points to the cubic. Left node here should be 4, and then the cubic is the cubic between 4 and 5. And since we're not at the beginning, we have that thing, and so we can analyze the cubic, find out where the extremes are and stuff. But then in this particular case, it turns out that it does not have an extreme. Okay, now maybe I can use this fact. So now I'm asking myself, this new case, which makes that test colon generalized, would that always be a case where the cubic does not have any extrema? Well, no, actually, because it could have a maximum, yes? So we analyze the cubic. It could have either not an extreme or it could have a maximum. So we don't know at this point. But even if it does have a maximum, then for sure it doesn't have the extreme that we are looking for. Wait a minute, the has extrema is plural. I think that is independent of the extreme type that we passed. Look, this initialize. I mean, I understand this. You know, the critical, it's just we have either the critical point is either set to the inflection point or the minimum or the maximum, depending on which one we are looking for. But this else, well, oh, this is just another block. Okay, that's the same thing. To the half square do you set anyway? S is the critical point. So the has extrema just checks if the signed square root of d is set, and that will be the case if we have called initialize. So, yeah, we just get the minimum of that cubic if it exists. If it does not have a minimum, it also does not have a maximum. So in this case, this would be false. Only the place where that minimum is might be outside of the current range given by left off and right off. And we also ignore it if it is just, yeah, humongously far away. I guess in the case that one of the well, the range is open, so you just anything till plus infinity is okay, but not really, because it must be less than humongous offset. So this more or less means if this is set, then we might have an extreme that is interesting. It's more like left has an interesting extreme that we might want to investigate and or jump to. So in the case that it does not have any extreme, this is not set, well, has not any extreme within the range, then this is not set, but it does not mean that we have to draw the conclusion that we are just on the way down to a minimum. Like, oh, this cubic has no extreme, therefore it's just falling. It's just not true. It could be rising, as we just saw. But whether or not it is falling or rising has nothing to do with whether or not it has an extreme. If it is rising and then has a maximum, which is ridiculous, then this is still not set, because I'm really looking for the minimum here. This returns the minimum because that was passed. The minimum was passed to the initialize here. So if the minimum is outside of the range, then it is not set. It doesn't matter that the maximum that it has a maximum, that it falls inside the range. Therefore, for the particular case that I got a notification that my parents joined Telegram one parent is already deceased, but okay, it's an old one, I guess. Old account. A quick look what that is. Happened before. My dad with Alzheimer joined the Telegram before, and then I said something and no reaction. So it is okay. It says just last seen just now. You would say that if then I react in 5 seconds, you get a message back, but no, nothing. No, forget it. Okay, don't mind. Hello, Troy John. Okay, let's see. So this particular case, I think we are talking about having no minimum. But it could have a maximum, but the maximum is not detected. Hence, we're talking about this not being set. Where this means the one closest to the last extreme, so left for the case where we're going to the right. And I'm not interested actually in what happens. I mean, if I'm going to reject this cubic, reject as in, oh my god, we need to probe for a new sample in between because the cubic looks like nonsense, I'm definitely not going to jump to a local extreme of the other cubic, which is on the other side even, which is even further away from the last one. So I need to concentrate on one of these two cubics, and well, the one that is the closest to the last local extreme, if they don't have the maximum, and then detect that it is not one of these special cases. Okay, formulated that. So I'm going to do that in this block. And then if we detect in this block that it is that special case, then I think what I want to do is set the keep going node and the keep going direction. And I guess this must be set to false. I'm kind of feeling like I don't need this boolean because it should be equal to keep going direction being equal to undecided or not. It's not new cubic, it's used cubic. If this is false and this is false, as is the case right now, this one could be true, you know. So it's kind of fuzzy. But that just means that we will be using used cubic, not new cubic. Well, I could have two cubics, where used cubic is like literally variable. Oh yeah, used cubic is set to left cubic or it's set to left node cubic or right node cubic. Down here. So that's going to be this one, used cubic. But that only happens if we have an extreme, left or right. Should it be setting using, I think I'm only setting it to false at some point. Yeah, it's set to false if we don't use cubic. So if use cubic is set but we don't want to use it for some reason, then using new cubic is set to false. But it kind of implies that we did find a new cubic to begin with. Or rather, I want to rename this thing. So this is the actual value. Sorry, I have to look here. So if this is still true, then we get here, and then I use used cubic. So it's not using new cubic, it is using used cubic. Let's rename it to use. Not using, but use. Use cubic. Now the color configurations and stuff are on GitHub. Damn it, man. I want to think about this. This one. So used cubic is defined if and only if. No, it's not true. Used cubic is not defined yet. Used cubic might be defined to either the left or the right cubic, which certainly only can happen if one of these is true. But might as well set it to false and only set it to true once I define the thing. Come on. Let's see, so I have used cubic. See how here it is set. I could set use used cubic here, I guess. But that would be the default then. But this happens if well, then this must be true. That's a bit vague. No, wait a minute, there's another else here. So use cubic is set here and there. So if I set use cubic to true, if I set this, I would set it in either case, which means I would set it here in this block, which means it would get set if right has extreme is true, and if that is false but left has extreme is true, then we set use cubic as well. So it's correct that use cubic will be set if one of them is set. So maybe that's the comment that I should be using then, instead of what I have now. So I'm gonna do use cubic will be set if either left has extreme or right has extreme is true. I'm going to change this into, I mean, used a cubic is set at the same time. So as long as this is a null pointer, then you can't use this because it's uninitialized. Okay, so the validness depends on whether or not that is set. And then I might define this one, but still set this one back to false. So I can hardly say that it is valid, that it is not valid if this is not set. It could still be valid. Although, yeah, well, but then we wouldn't want to use it, but okay. So I have to set this to false at the same time that we set this. And on the other hand, if it is already set to false right here, because we don't have this or that, then these need to be initialized as well. Let's see what these are defined. Okay, they're defined here. So if at some point then the use cubic is set to false, then we do get here, and then We make a step from either the left off or the right off. Border. So not understanding this, I must say. Just sits last. Here they said as well. See, that's what I mean. It's just double. It's double. What is this? If you use Google, oh, adjust left off or right off. But I mean, this expression, Boolean expression, and the use cubic, they are the kind of each other's equals. Good. Feels like I should remove one of them. Well, remove this one then. So either we do the jump or we did use the use cubic. And in which case I have to adjust the range. Yeah. Doesn't make it easier that the code is totally broken at the moment. So I guess that if keep going direction equals undecided, then we should use the use cubic. So I'm going to remove the use cubic, which means that keep going direction should be undecided. So then the story becomes more like if use cubic isn't set or shouldn't be used. Then keep going node and keep going direction will be set. I think this guy just delete it. Yeah, hello. Okay. So again, in this block I'm going to detect the new problematic case. Once detected, I want to skip all of this. Oh wait, I must get rid of that first, sorry. So that's the same thing now. Use cubic equals h directions unequal undecided. No, that's not true. Wait a minute. Yes, no. Yeah, what? Oh, h direction. Never mind. Yeah. Use cubic is equal to keep going direction is equal to undecided. No, equal. So we're not doing any keep going stuff, and H direction is unequal undecided, which means that we have a last extreme cubic. Then we enter this block, which means then we will not enter this block if this special case is detected, because then this is being set to something else and undecided. So here I should set keep going direction. It's like, is that not just always H direction? No, apparently not. I don't know. I think it's probably just a local extreme edge. So instead of setting use cubic, we just set keep going node here, which is then the same thing. Direction, I meant. Okay, I got rid of that variable. But. Okay, so if this special case is detected, then we want to end up with this is false. Going node must be set to something. The keep going direction must be set. What else? That's it, I think. Because then we will skip this one. And this one. and the keep going direction is not equal to undecided, so we'll skip this one, and we will skip this one, and we will not skip this one, and therefore jump to keep going node in the correct direction, which I think then again maybe that code has to be fixed, but anyway. Thing that I just added. I'll say this makes a lot of sense as well. Okay, I think I'm going to delete this and then do an initialization just based on the fact that that was set. And then down here, so this is column 13, 15. Do we definitely get here? And I could do here if it is, well, if it is unequal, so that means that here also we do that and then do this initialization down here. To avoid the code duplication. So it means that now I only have to set keep going direction, and then this is initializing the stuff, and then this is skipped, and then we do this. So then you would say, well, if you skip that anyway, you might as well move this up, and which is true unless keep going direction is changed in the block that we just skipped. But it seems very unlikely because then it was already set. So if I search for keep going direction, I find that it is bloody set. Yeah, here. Okay. So even though it was not set here, so it's still undecided here, but then it might still be set in this block. But then the keep going node is also set already. And as is that. So oops, it's not working. Oh, wait a minute, actually that is working. If I do it in this part, we do. The cubic used is set and the keep going node is set. Chain reuse, all that stuff. Yeah, okay. So that then might also happen in that block. And then we can still detect this and then just jump to it. I think that should work. Probably not. It's like I don't have a clear picture. It's like a bit fuzzy with holes in it and stuff. But I still keep the faith that in the end I can make it work. First it has to compile and then by running the code to probably get the kinks out. Now, first of all, I don't want to influence the you mean the colors. Look at the link that I pasted. It's new with my own syntax highlighting stuff. If this block does not detect the new problem, then it should behave as before. Which means, let's have a see. Let's see, we have a right extreme. Well, I would even begin with that. Okay, if we have a right extreme and we don't have a left extreme, or the horizontal direction is to the left. Oh, okay, we don't need that. I don't know that yet, so there's no preference for left or right. H direction on, well, whatever. Choosing that because blah blah blah. I'm just setting a use cubic and use a cubic. Yeah, so if the special case is not detected, then we're going to use a cubic, if any at all. And well, this one, which is detected here. So use cubic and use a cubic are now set. After all of this. And then the keep going direction is still undecided. And if the H direction is not equal to undecided, then we enter this block. Which, oh boy. Okay, line 434. So this would be initialized to the same thing if H direction is unequal or undecided. And it is unequal undecided because it was tested here. So this is already defined. Then we could set the boolean use cubic adjacent to last extreme. Well, that's really referring to the used cubic. This is set here. And then I start testing stuff that has to do with the new problem. But this is new code and I should not have to do this here anymore. Let's just comment out with new code, I think. I think that I should be able to find in the div that now this block is not changed and this line was changed because I don't have that thing anymore. So I'm going to have a look at the git div. Oh, draggable, really? Algorithm. Okay, so these are the new variables, and this is the new block. That assert was moved elsewhere, I guess. This was removed. This was added. This was moved before that point. And this was removed because each direction is unequal, horizontal direction undecided. It was already tested here, so that was nonsense. And then also for the F, is that an indentation change? Because I don't believe I deleted all of this. Or it just gets confused by my if zero endif. Nah, come on. No, no. I changed so much that the div is unusable. So this looks like the same code as above. Oh, that's the indentation change. This is also new. Okay, now we should be able to see it with a -W to ignore this white space change. So in algorithm, that's here. We have this new block and then the things that I just said, and then we have that commented out part. No. No, I don't see it. I would say that div is a bit unusable. So what is this trying to do? Oh yeah, right, that. This is yeah, very heuristic code that tries to guess if the new cubic deviates too much from the fourth degree polynomial that was fitted. But that we can only do that if the cubic is adjacent to the last extreme to begin with. That we don't have anymore, so I think I should just do this, which then must be defined, of course. So that would be this. For example, if we go right and the use cubic is defined to be the left one, and the local extreme edge equals the use cubic, then apparently it is immediately connected to the last local extreme. And in that case, we do some magic here, which ends in this test. And then if the less than 1.8, then we say the cubic deviates too much, so then we want to just do a step. Otherwise we want to use that cubic, so we don't set keep going direction, which means that it is still equal to undecided, and we should go here. And then it jumps to the used cubic, to the minimum of the used cubic. I wouldn't know in what case we got here, to be honest, but apparently that's also possible. What is that doing? So in this case we did not want to keep going, but we don't have a used cubic at all. You notice change begin, there is no left cubic, and the right cubic has no blah 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 blah. So what do we do then? I guess this works. It's old code. I don't want to look at it. Let me concentrate on this new block. I think it's important that we don't crash or assert unless we get here, which is new. So I'm gonna put an assert here. So now I can finally test if this compiles. Probably not. Well, this is after the assert, but maybe I can fill it in. I think I should just set this to H direction. Now it compiles, so now we can try running it, I guess. Duh, crash already. Assertion false fails there. What? Yeah, I'm not really testing anything yet at all. So we always enter this. Well, as soon as the direction has been, H direction has been decided, we get there and then assert on it. That's not what I want. I have to implement a little bit. But hey, it compiles. So then, okay, we get here and then local extreme edge is that, and then we get whether or not the cubic is adjacent to the last extreme. I might not have used cubic at all, so this is not correct. Let's see, if we go to the left, you must have the right cubic. This case, in the example case, we go to the right. The local extreme edge, it must then be the left cubic, which is actually just this thing here. That is left node, isn't it? Yeah, that's why it's called node. Okay. So if we go to the right, is it certain that we have a left node at all? That would be the sample on the left of the new sample. We're going to the right, so yeah, I mean going to really, we're not completely in the beginning. Otherwise this would have been equal to undecided. So there should be a point on the left if we go to the right. That's not the case. I think this thing is not undefined. It's probably set to chain end something or... Oh, it's not defined. It's undefined shit. So if it should be defined unless the new node is at the beginning of the chain. But if it is at the beginning of the chain, I really doubt that we're going to the left, to the right. That's kind of impossible. The problem is that we won't crash if we test on an, if left node is uninitialized, we won't crash. It's probably just going to say that it is unequal. But this one would crash, and that's half of the case, so they can't dereference it. So I probably will still catch a case where it is undefined if that ever would happen. So for now I'm gonna leave it like this. So we go to the left, then the node on the right of the sorry, oh, go to the left. Yeah, we go to the left. So the local extreme is there, and then next node means that the right node would be this one. I can't follow that. No. The first cubic tests on is equal to chain end. What kind of bullshit is that? And this point is undefined. Oh, here just initialized. Duh. Yeah, so it is right now. It is just the one on the right of new node. I don't get it. Just say you have this point and this point and this point are used. These three are used to fit a fourth degree polynomial. I collapse it vertically, so I just put everything in one line, but make this as, you know, a parabola or something. Then one of those could be, no, then either this part or that part, likely, I guess, is the local extreme cubic, which even doesn't say anything. So the local extreme could be everywhere, as in close to this one, or close to that one, or close to that one, or close to that one, close to that one, or close to that one. So one of these positions we have the the maximum or minimum. I want to concentrate on going to the left. So we go to the left. That means that we added a new example here. This is right node. This is just right node here. The node on the right of the new sample. So this is new node, this is right node. Left node either does not exist or it does exist, and then it would be like here. I really don't get it. I would say local extreme edge, which is the edge of the three that were used for the polynomial fit, equals right node. Then it is adjacent. Why next node? I think this is team said this is correct, but okay. I think I did something similar somewhere else and I copied it from there, but that code that I copied it from was never tested. Maybe it's now actually it is used here. Oh, but here it says use cubic. Oh, idea that's different. So if you go to the left and the used cubic equals the right analyze, sorry, the used analyzed cubic equals the right analyzed cubic, then the used cubic equals the right cubic. Then the used cubic itself is the new node. And then the next node must be the local extreme. This is correct. And if we go to the right, and this is true, then use cubic equals the left cubic, which must be equal. Yeah, this is correct. I don't know what I did when I copied it, but I wasn't very accurate. So we don't have a used cubic here, so it's not never set. I have to directly compare it with the right node and left node. I could probably do the same below, but yeah. Okay, so if and only if this is true, we might want to do something being that. And the thing I want to detect is that the adjacent cubic, we must find the adjacent cubic. I just need to test on cubic, so let's give the thing a name. So here we're talking about the cubic is my cubic adjacent. It's more like it's more like is that so the cubic is adjacent. No, it's not really. This is cubic. Maybe just leave out cubic. If we go to the left, then the local extreme edge equals the right node. Left, right. Go to the left. To the right node. Then the new node is the cubic. Do I have a new node? Not even sure, actually. Okay, I probably do. So how did I get my right node again? See, new node. We have a new node. H direction. So we're going to the left, then you first encounter this thing, and then further to the left you get a new node. Then that would be the cubic that spanned between new node and the local extreme edge. And if we go to the right, then just simply this thing is the cubic. Well, it should be. And we go to right, so I might as well say left node then, but well. Okay, I'll say left node, but it's the same thing. Hey, left node is shorter. And then we can even abbreviate it a tiny little bit. Either new node or left node, and then take the cubic from that. Oh, wait a minute. Actually, this is a sample node iterator, so I don't take the cubic yet. This is just the node that points to the cubic that we want. Yep, and I also need I need a analyzed cubic. And that kind of sucks because I'm not sure I have that. No, sure we have that. Okay, so I think that above we used left node cubic. See, to initialize the left a cubic. And the right a cubic has been initialized from the new node cubic. So if I have set it to new node, then the right a cubic will be initialized as well, and otherwise the left one will be initialized. So I can define a pointer to them, to the right a cubic. To the left is left and new is right. No, just an analyzed cubic, so I don't need to use a pointer. We call it const reference. And okay, so now we have the adjacent cubic and the analyzed thing. And the problem occurs if, well, for sure, that thing, that cubic, does not have the sort for local extreme. That's prerequisite number one. And now we're getting very close to code that I commented out somewhere here, down here, I think. So maybe I should copy that. Maybe we should just move it. Where shall I put it? Yeah. Okay, let's say I probably need both of those. Something, a little more indentation. I already have that. What? Okay, whatever. So we're talking, I think we're talking about, say, it's approaching sort for local extreme, does not contain a next sort local extreme, and has the expected ending. Yeah, I really wanted this actually. To definitely skip the local extreme. That kind of should be the same thing. Maybe do that. And then move this as well. Okay, well, let's try this. Let's try this. Maybe you still assert, you know. Then, yeah, the detection would more or less be correct, I guess, if that happens. Random. Yeah, I thought I added a brace, and then I said I would already have that, which was really weird because usually I add braces in pairs. Oh, there's a brace missing here. Or brace too much. Yeah, it's gonna be in the neighborhood of my assert. Assert false. Here. Oh, it does not match. It does not match. I just forgot. Okay. Damn it. Okay, but is it an access to a bad pointer? At least not my assert. I'm using use cubic here. What? Oh, right, of course. Of course. No problem. Nothing is wrong yet. So I'm using a use cubic here, but it's that was not possible, and that's why I got my adjacent cubic here. So instead of using use cubic, we should use adjacent cubic. Do I have an A cubic at all? No, yeah. So this must be adjacent A cubic. It's hard to believe, isn't it? Just no, it's not a pointer anymore. For some reason I made it a reference. We got one further. And even that one worked. And I didn't detect it. Seriously. Okay, well, it should have detected that this cubic going from here to there does not have a minimum. Oh, wait a minute. I'm only detecting if it is on the other side. So it goes down again. Well, this is also wrong. So if the end is not correct, if it does not have a minimum and the end does not correspond to going down in this case, then it's also wrong. Yeah. It would make your head hurt if I ever had headaches, which I don't. Well, if I have a virus, I do, of course, but not from thinking. So that definitely skipped the next local extreme. It's not true here, but what is true is that we are not having the correct end. The correct end here is downhill, but this is false. So we're not. What the fuck, dude? Does not contain the next thought local extreme. This is true. This is false. So this is false. But it could also have been false because this is true. Man. Hard to wrap my head around this. I think this one is correct, but I also need to detect the case where it is still going up. So this is false. And it's not going up because he passed the minimum. The naming of the variables here is crucial, but I don't think I got them right, fortunately. I don't want to redo this, so now I have to split it up in a different boolean. Let's say as expected and for approaching sort for local extreme. I should use this actually. The cubic ends with the slope is expected, but that's a bit long maybe. Cubic ends with, leave that away, so then we get expected end, is good, when not. Maybe slope. So actually also this, isn't it? Rely on the compiler to short circuit that. It's an inline function anyway. Okay, now my hesitation is because this can only be true if this is true. And this can only be true if this is true, which can only be true if this is true. So this can only be true if this is true. Even though I'm testing it in two places. Which I totally agree with, but I just hate it that I'm testing it twice. Yeah, nothing you can do about it. Yay! So I detected it now. So this should be this case, approaching the wrong local extreme. Yep. So the reason is that we're looking for a minimum, but the cubic that we find is just going up, 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 clearly to its maximum. It's like, huh? This is a maximum, so it can never skip a minimum in a way that it just looks like it's going to a maximum. And in order to test the other one, I would have to put it there, but well, I'm lazy. No. Cool. So I guess it works. Maybe add some debug stuff here. Debug output. Okay, so now at the moment that we add this one, it has rejected this cubic and it just makes a scale jump to this point, saying using this cubic, however, but there was not any cubic detected at all yet. Should phrase that differently. Let's say something like ignoring cubic adjacent to or something. Ignoring cubic adjacent to last local extreme. You should be able to get a local extreme. Ignoring cubic adjacent to last local extreme, namely 3. There's 3 here of type maximum, because, well, it is a maximum. Because it's heading for a maximum again. This thing is heading for a maximum. Yeah, that makes sense. So now we go here. And then we go in infinite loop. Why? It should just jump to this minimum here. I have to go to bed though. It keeps doing this. So it says it's not using this cubic. Yeah, who cares, I would say. But still. No, wait a minute. Now the cubic, maybe name cubic is not good. I should more say the jump point. So it wants to ignore the jump point 6 because of something, and then of course we also don't look at any cubics that were formed. So we have a cubic between 6 and 5 and between 4 and 6. But instead we just want to make the scale jump again, which ends up in an infinite loop because we already did that. So it jumps again the same distance and comes here, and if reject that, then again jumps the same distance. So it just keeps jumping and jumping over and over to the same spot. So it should not reject that thing at all. If only because it was a scale jump, but also not because I don't see any reason why we do that. It is not using the cubic because it contains again and only a maximum, which is true, meaning it completely missed the next local extreme. But the maximum that it contains is super close to 4, and therefore we should not get this. So I would like to I should just set a breakpoint, I guess. Well, this is just going nowhere. I suppose I can set a breakpoint here. 397. Control top. Yeah. As I say, 397. Just continue. Yes. This should be yes. This should be no. Whoa, big. Too big. Oh, wait a minute. It's an coordinate thing. 5.67. I don't know. Did you just print this? So 4 had this coordinate, and then, well, it's a little bit further. Definitely skipped. Well, this was true. And has the opposite extreme is true, I think. Adjacent cubic type is a maximum. Yep. And then each direction times get the other local extreme, which would be the maximum. Okay, so print get other local extreme. It's in 6.6. Yeah, I mean 6.6 is definitely far away from the 5.67 stuff. Should have been between these two values. So apparently we are not getting the correct extreme here. Oh, wait, huh? What? Yeah, the adjacent cubic is this one, which just has a maximum here. Huh? What? Okay, I'm confused. It is 4. So the thing between 4 and 6. Other extreme is a minimum probably. Yeah, that's better, but that's still too far away then. Oh, right. Yeah. That's very far away. But okay, so why is this thing having... Is it initialized with the maximum? Has it been initialized with the maximum? I'm looking for a minimum, man. So I don't get this. Clearly, and I think it's a bit... Oh, wait a minute, 5.86. Yeah, no, it's nonsense. That's totally nonsense. So that's this one. That's here. So this is not the adjacent cubic then. It's this cubic. It's the wrong cubic. No. What? Why? I want the maximum of this cubic here. And that should be super close. This cubic is going through 6 and 4. Can not be anything else. Where did we get 6? Oh, that's a while ago. Local extreme edge is 4. Adjacent, I must have the... Yeah, it's also 4. Makes no sense. Or... No, makes no sense. it's not the same cubic. So we have a different analyzed cubic. This analyzed cubic doesn't belong to the cubic. Adjacent cubic is one thing, and then the adjacent A cubic does not belong to this thing. That's what's wrong. Hello, Qasim Ali. I should have gone to bed 1.5 hours ago, so yeah, I'm really calling it a day now.